Hello there. So this is my video talking about the series that I'm going to be making, which is essentially automate building a lab, and we're going to be talking about, we're going to talk about the pros and the cons. I mean, why you should be building a lab, and what are the pros, what are the cons, obviously, and we're going to talk about a lot of issues, really, why it's important to go through it. But essentially, what I'm showing you here, you're probably wondering why I've got these two screens on there. What I want to show you is essentially what network programmability is all about. As you can see, this entire infrastructure. So we've got a spine and leaf topology here. So I'll just start with the layer one of the deal. So I'll start with the from the top, work my way to the bottom. So obviously we've got a patch panel here, and we are using hardware wise, what we're using is a Cisco 3750X's and 3750Gs. Now the X's are capable of SFP 10 gigabit Ethernet modules, which I haven't upgraded to fiber at the moment. So we're capable of running multi-mode fiber, single mode fiber, but multi-mode obviously is what we want. We're not going to be running, 200 meters links. So that's the key. So but at the moment, that's the hardware. So it's a spine and leaf topology. So what that essentially means is a cloth fabric, and we're going to talk a little bit about that on hopefully the forthcoming video. So this is just an introduction, a prequel, if you like, towards the actual series that I'm going to be making, and my goal is to hopefully sorry, I just can't see, I feel literally blind without my glasses. So my goal really is to help you build an infrastructure. It doesn't obviously it's not going to be similar to this. As you can see, there's a lot of equipment here. There's a lot of firepower here, but we're not going to be focusing on just building, but how we can automate the entire infrastructure. So as I mentioned, again, this is on a layer one. So the physical, we've got a spine and leaf topology. We've got two spines and three leaves. This is a campus style spine and leaf. So we are using VXLAN, but there's no ACI, and I will talk about that in my future video. What else have we need to cover on layer one? So yeah, obviously the cabling. So it's a Cat 6. Is it Cat 6A? No, I think it was a Cat 6. Sorry, what we're using here. So these two that you can see at the bottom. Let me just see if I can draw on it. So these three here. So these are two. Sort of I think it's 100 megabit switches. So I think these are two layer ones. Sorry, I think this one might be a layer 3, but I think this is a layer 1, layer 2, sorry, switch, and this is a layer 3. I use these mainly as a management network, but I'm in the process of migrating this all. That's why you've got all these cables out and changing this entire sort of infrastructure and focusing more on a virtualized infrastructure. At the moment, there is a virtualized infrastructure, but it's more compute. Is all the compute is virtualized. So that's the switches, and that's it on a sort of layer one, and I haven't gone down to the compute. So at the bottom here, we've got my three different servers. The first one is an HP 380 DL. DL large form factor. It's a G9. I'm very, very fortunate, and to have this. It's very, very. I mean, it's quite new, and it's a G9, so it's quite a powerful workhorse. Really, it's capable of Intel V9s. And I'm sorry, capable of Intel V4s, and it's a G9, so we can have up to maybe possibly 88 threads, which probably means up to maybe 88 virtual machines running at one time. Obviously, if they're using a single thread each, so it's a very, very powerful, and it's using a DDR4, I believe, on this. So it's quite. And the second one, we've got the HP 360p. The G8, sorry, again another wonderful, but this is the small form factor, so it's using the 2.5 HD discs, the serial attached discs. So So again, these are this is the and the last but not least, we've got a G7. So basically the previous model. So we've got the G9. I mean, the only thing that's missing from this probably a G10, but that's way beyond my spending budget at the present moment in time. At this present moment in time, so it's so that's that really on the physical layer and layer one. So just moving over to layer two, I think what we're using there, it's, and this is an issue with spinal leaf, I think this is probably a con spinal, it's the amount of cabling that you're going to need, because we're essentially connecting each leaf to each spine. So each spine is connected to all leaves, and you know, the leaves will connect, but they don't interlink. So the leaves don't never connect to another leaf, or the spines doesn't connect to our other leaf. Um, and so we've got we're using I was using this initially a stacking Cisco's proprietary stacking cable, which is the stack wise, to stack these two, but I've taken that out simply because I'm using, I will get to that in a minute, on layer 3, some routed ports, but I will speak about that in a moment. So we've got port channels, ether channels, I should say. So ether channels is essentially bundling up the physical cabling into a single logical cable, so that the other device that's connected to this only sees a single link. That way it will prevent spanning tree protocol from initiating, and also you are essentially increasing the bandwidth, not necessarily, not the speed, because I think a lot of people get that confused with the speed. So here's one right here. So this is connected leaf 1 to spine 1, and it's not necessarily I mean, it's not the speed, it's the bandwidth. So think of it as a highway, and it's increasing the lanes on the highway. So it's increasing the bandwidth of the link, which is really good. I mean, if you've got multiple VMs and they're sort of, you know, streaming, so you don't bottleneck the network. So it's really good to use port ether channel. It's actually this port channel that I'm using, because I'm using routed ports, and it's a layer 3 spine and leaf topology, and I will get to that in a minute. It's actually using a layer 3 ether channel, but from my understanding, ether channel is inherently a layer 2 technology. So that's that. So that's on a layer 2 now. Moving over to layer 3, which is essentially the underlay, what we call the underlay on a spine and leaf. We are obviously using routed ports, so we have a layer 3 link between spine and leaf. We're using a point-to-point links. We're using I think we're using a 30. No, sorry, actually, I set it up as a 30-bit IP address, so it's a point-to-point link, a /30 CIDR notation. So essentially the subnet that I'm using on all of those point-to-point links, I think it was 255.255.255.252, I believe it was. Yeah, for /30. So that's that. And it's a point-to-point link, so spine connects to all the leaves point to point, and the leaves and the leaves will connect to both spines, and that's on layer 3. And also what I forgot is the actual OSPF. So I'm running a routing protocol. Now you can run on a spine and leaf, you can run any protocol, an interior routing protocol of your choice, really. Can't speak today for some reason. So you know, you could use ISIS, you could use BGP, OSPF, but I think it's BGP and OSPF that's mainly used from what I've seen anyway. Again, this is a campus style, so it's not, you know, completely sort of emulating the data center. So that's on running OSPF. So OSPF is basically running a point-to-point advertisement. So it's not using, you know, a sort of a DR and a BR, which is basically your backup route and your designated router and a backup router, which essentially says that it's how OSPF makes its advertisement. So what OSPF does is basically it advertises its link states and the neighboring link states, and the way it does that is it doesn't do it directly to the router that it's connected. They usually select within an area a designated router, and also a backup router. So designate router will hold all the routes of that, and it will also create a backup router. So the designated router would essentially hold all the routes, and all the routes are advertised to the designated router. Its convergence size is very good on a link, because it's a link state protocol. It's quite heavy on this, the resources of the actual switch, which can get quite heated at times. But that's that on that. Also, it's using ECMP, which stands for equal cost multipath. Now, the reason why we use ECMP, especially on a spine and leaf, is that we essentially have, because both, all the switches are connected, all the leaves, sorry, I should say, are connected to the spines. Um, each sort of leaf is about a hop away from its destination. And plus you've got two links. It has two paths towards its destination, so it can use both paths at the same time. So it can have, basically, it can split the packets up onto both paths, and it creates, it creates redundancy. It's absolutely wonderful to have, and it's just much more a efficient way of doing things. Obviously, we enabled spanning tree protocol. I should have talked about this on layer 2, but we use it. We should always enable a spanning tree protocol as a precaution. You should never disable it, even when you're using a layer 3, because it is a precautionary a method to stop loops, really, and broadcast storms. So that's something that I probably will make a video about. So that's pretty much describing to you there on a layer 3 what we're using there. So that's that. And as you can see on the right hand side, now I'm going to go to, this is the actual development. So this is the programmability that I was talking about earlier on, and the automation side. This is what really gets my juices flowing and makes me really excited. I am honestly cannot describe to you how I am passionate about this field, because when you look at this entire infrastructure, yes, someone has to physically all connect it up, and someone will have to write down, shame on me, I'm not using any labeling, but I didn't need to, because I knew which port that it was going to. But obviously, I'm using labeling for the backplane of the basically we're using we've got a labeling on an entire backplane, so the patch panel will have the the backplane of the patch panel and all of these, so we know exactly which one is which. But at the front, as you can see, someone would have to physically do all this, write down the name of the ports that it each is going into, so which port channels are using which on the spine, which one, you'll have to write this all in a spreadsheet and so forth. But what the great things about it is that in terms of configuring each device, so going into each device, in ID, so these are iOS 15, I think, I've all there. So in terms of going into each device and actually programming, configuring each device, so going through enable, and then going into exit mode, and going to configuration mode, and typing in config, in configuration mode, and just typing in the interface name, and interface gig 0, whatever port channel that you're currently using, but interface gig 5, or whatever it may be, /5. But instead of doing all of that on each switch, we don't even have to go into the CLI. I mean, obviously we need to go into CLI to set up SSH and all the others, because these are pretty much CLI sort of iOS based operating systems. There's no sort of zero touch provisioning on them. But I also made something to make that easier, but I'm going to talk about that a bit more. I made a module that uses the serial actually uses the serial module on Python, which automates the onboarding process for the iOS. But I will talk about that in another video. But as you can see from there, basically, if you have a look carefully, we have not, there was no need for me to go into all of them just to set up, and SSH on each switch, but everything was done through code. So it's basically, I'm sure you've heard of the term as, the infrastructure as a code. This is, network as a code, essentially. So this entire network, all the configuration, we're pushed through Python using a module called Netmiko, which is a wonderful module. I think it's based on Paramiko SSH module. Um, and we are essentially configuring the entire device, the entire fabric, network fabric here, through code. It's a very crude code. It's a very procedural based code, because at the time I just wanted to get the lab up and running. I mean, I didn't sort of, wanted to create a sort of an object oriented program, which I could have probably done. Created classes and created class attributes, or even um, um, object based attributes, so even instance attributes, and created functions and methods to do all of this, but there was no need for that at the time. It was just get it done, is it working, and get it done. And it's all procedural based. Now it is a procedural based, but it's very declarative, so it's not imperative coding. This is quite declarative coding, and I'm going to talk about that a bit more. Hopefully I might make another video on that, actually, talking about that in a bit more detail. So that's that really, and this is why I would like to show you this on this intro sort of video, is that we've essentially automated this entire infrastructure through code, and I'm going to teach you how to do that, from what I've learned and what I'm still learning, actually. And the thing I love about DevNet is there isn't one tool that can do it. I mean, you can pick one or two tools. You have to pick a range of tools. So these tools will include, infrastructure as a code tools such as Terraform, for the obviously the virtualized infrastructure on the hypervisors here. Um, you could use that. You could even use a module, the API module for whatever hypervisor you're using, whether it's either ESXi or Hyper-V. There is a module, I'm sure, for it in Python. If there isn't, I'm sure there is. I mean, if there isn't, I'm sure there is. There you will be able to find it somewhere. I'm sure if it's not made by, what I mean is, if it's not made by the official channels, there's probably someone has already done it. But I personally like to use an interface. A infrastructure as a code tool, and my choice is Terraform. It's just an amazing tool for virtualized infrastructure, and it just allows you to build virtualized infrastructure and virtualized resources. So you can use it for your on-prem virtualization, so which you're probably going to be having if you want to build your own. But virtualized infrastructure is so important to have, or even on a cloud, or on a private cloud such as this. So that's that. And obviously, my language of choice to use is Python. I love everything about it. It's, again, something that excites me the most. If you are just getting started on Python, there are a few books that I'm going to put down on the recommendations, hopefully. One of them, I think it is, it's called Automating the Boring Stuff. I can't remember who it was by, but it's a wonderful book. There are a few books, actually, on Python, and I remember some of the other channels that contribute to the DevNet community, such as Duan Lightfoot, Network Chuck. I mean, there's so many. The community is so great out there, and one of the best place that I've learned my resources is probably CBT Nuggets. They offer such a wonderful material. Duan Lightfoot is amazing. I mean, I can't really think of any words really in the vocabulary to describe what he's doing for the community. He's such a amazing guy. So that's that really, and so that's what I wanted to show you today. And so, as you can see, I'm not going to run through the entire code, but as you can see, we've got this is the code, and this is the configuration that's been pushed to each switch device. So we've got VLANs here. So we've got this. So just to give you an example, so this is all the configurations for the spine 1. This is all the configurations for spine 2, for leaf 1, for leaf 2, and for leaf 3. And essentially what this code is doing is just connecting to these switches, and it's just a loop. There's a for loop. We're using a nested for loop because we've got a nested YAML configuration file there, and it's just literally looping through the configuration files, and it's pushing all of those configurations onto each device, so its associated device. It's just wonderful. It's wonderful to think that you can, program all of this infrastructure by code, by all of this, without you having to manually go in there and sort of and do it yourself. I think it's just wonderful. And I think, nowadays when I think of network engineers, and I no longer think of I've said this before as well. I no longer think of guys sort of doing a BGP peering, or advertising subnets on OSPF and so forth. When I think of network engineers, I still see them doing that stuff, but I see them doing it on a much sort of greater scale, like just literally, sort of from programmability side, doing it on a the DevNet way, so to speak, and treating these hardwares sort of like software development, and pushing, doing it on a much larger scale, pushing multiple configurations to multiple devices, and also retrieving information from devices, because I think the read only is very important. Now it's, it has its downside, automation. You don't want to copy and paste something that you saw online, a code that you saw on Stack Overflow or something, and just put it into production. I don't think that's something wise to do. But it's I mean, it's just amazing. It's a whole sort of another turn, and I'm very excited. And hopefully, this is like a prequel to the series that I'm going to make. I'm going to try do that video a weekly on how you can start in making your own lab, but most importantly, how we can automate the entire infrastructure. That is what I'm going to focus on, and not just, there's plenty of videos out there. I think there's enough resources really on how to create your own lab, whether it's virtualized, whether it's hybrid. We've got a hybrid here, but let's talk about automating the entire process. Let's talk about how you're going to automate this entire process, how you're going to create a virtual machine, and without you going into GUI and clicking and basically turning into click ops, how we can just automate the entire infrastructure. I want to create a new VLAN. I want a VLAN interface to associate with it. I want it to use that specific trunk port. Here's the VLAN interface IP address. Here's the subnet that I want it to use. I also want, on the other end of the virtualized environment, I want this particular vSwitch created. I want this port group VLAN created on that switch, and I also want virtual machines created on that switch that links back to the VLAN that we created on the switch, the physical, and I want it all done automated. And that's what I'm gonna try and hopefully do. I'm gonna see if I can do it live, but things never work when you're doing live demonstrations. So that's the purpose really. Again, hopefully see you on my next video.